What's up everyone, welcome back. Patrick here, moving on to the next video dealing with a difference of squares. So we got to factor these over here and notice that all of these expressions are going to be multivariable expressions. So before we were dealing with a lot of expressions, we were factoring expressions when they were quadratics in terms of the difference of squares. These here are going to be multivariable expressions, which you will probably run into as well. So as a quick review, what we're going to be using is the formula a squared minus b squared is equal to a minus b, a plus b. Now you may have different methods with how you go about factoring a difference of squares. In the overview video, I mentioned how you can do it with decomposition even if you want, but this is a common formula that is used, so this is what I'm going to be using. Where if you have something in this format, basically these two expressions are going to be the square root of that first one, then you're going to have a minus and then a plus, and then this last expression is going to be the square root of this expression over here. Now part A, it's actually really easy because notice that it's the exact same thing as this, except the letters are different. So notice that the a value is x, so let's actually just write it over here, just to keep, or just to start off the pattern that I'm going to be using throughout the video. But basically notice that the a value is x, the b value is y, and so we just have to plug in those into this formula. We end up with x minus y, x plus y. So fairly simple for this, this first one. Okay, but with these other ones here, it's going to start getting a little bit more complex. Now, first thing we always want to do, like with anything we're factoring, is we want to check, can we factor out a greatest common factor initially? And notice that over here we have a 2m squared minus 18n squared. Can't take out any variables because there's an m here but no m here. There's an n here, no n here. But notice that 2, 18, we could take out a 2. And so if we take out a 2, what would we be left with? We'd be left with m squared minus 9n squared. And so then what I'm going to do is I'm going to take this bracket alone, and then I'm going to factor that. So m squared minus 9n squared, that's a difference of squares. Notice we could take this, we could rewrite in this format as m squared, that's already in that format, but this 9n squared, we could rewrite that as 3n squared, like that. Right, so if I take this, rewrite it here just below the formula, so you could see how we're going to be using the formula fairly clearly. Notice that in this case, the a value is m, and then the b value is this 3n in brackets. So then we just have to take these expressions for a and b, plug it into that formula. So we'd have a minus b, so m minus 3n in this case, and then a plus b, which is m plus 3n, like that. Okay, but remember, this is our main expression that we were working with. So first we factored out the 2, and then we took this bracket and factored it into those two. Sorry, I'm kind of going all over the board here. Feel free to organize it better on your paper, but hopefully you're following along with what I am doing over here. All right, so that would be the final answer for part B. Now let's move on to part C. We got 48 x squared minus 147 y squared. First thing we check, greatest common factor. Notice we could take out a 3 from everything. So if we take out a 3, we'd be left with 16x squared minus 147 divided by 3 would give us 49, and that's going to be y squared, like that. Okay, and then this bracket over here, if we do it on the side, 16x squared minus 49y squared, we could rewrite both of these expressions as 4x squared minus the 49y squared, we could rewrite as 7y squared. Okay, so notice that compared to this formula, let me just separate that. So with this formula, notice that the a value is 4x, the b value is 7y, right? Notice how this is in this format. Now this a and this b doesn't have to just be numbers or single variables. It could be entire expressions like this over here. Okay, and so taking those, plugging it into the formula, we end up with 4x minus 7y, 4x plus 7y. Now, remember, we had that 3. This is the main work here, and then we took this bracket, worked with it separately. This bracket factors into these two, but we still got that 3 that we took out in front. So we end up with those factors right there. Took the 3 out initially, then took that bracket, factored into those two. Then moving on to part D, we got negative 25 x squared plus 64 y squared. Now over here, notice that a difference of squares, there's got to be a minus in the middle. Notice here there's a positive in the middle. So there's two ways to go about this. Notice we could just rearrange this actually. So I'm going to show you two ways. So we can rewrite this as this over here, right? This and this, they're the exact same thing. And now it's in that difference of squares format. We have to just change these expressions to be 8y squared minus 5x squared, right? This and this are the same. And now notice that the a value is the 8y, the b value is the 5x, and then we just got to take these, plug them into the formula. We end up with 8y minus 5x, 8y plus 5x. Okay, so that's one way to go about it. So that's one set of answers. If you want to keep the x in front of the y, another thing you can do here, this may be a solution that comes up in certain textbooks, is you could actually take out a negative initially. And then you maintain that format of where the x comes before the y. So that's another possibility you could do. You take out the negative, and then notice that this is a difference of squares, and that's going to factor into 5x minus 8y, 5x plus 8y, like that. Okay, so that's another way to go about it. So these two brackets multiplied, and then these three expressions, these two brackets, and then this negative 1 in front, they're actually the exact same thing, right? So just wanted to mention that maybe your textbook might show this answer, but this answer is correct as well. They're all the same thing. If you expand them, you'll still end up with that initial expression, right? Then moving on to part E, we got 400 x cubed y minus 36 xy cubed. Let's actually write it over here. So notice in this case, we can actually factor out variables initially too, because notice that this and this expression contains an x, and this expression and this expression contains a y, so we're all good. So we could take out a 4 for sure, right, between 400 and 36, so 4 would be common. Notice we got x to the 3, x to the 1, so the lowest exponent would be x to the 1, then we got y to the 1, y to the 3, so we got y to the 1 right there. So to see what we're left with, what we would do is we would just divide all of these by 4xy that were taken out. 400 divided by 4 gives us 100. The y's cancel out. X to the 3 over x to the 1 gives us x squared. Minus 36 over 4 gives us 9. The x's cancel out. Then we got the y squared, like that. Right, so we took this out initially, and now notice that this is a difference of squares, because we could rewrite this as 10x squared minus the 9y squared, we could rewrite as 3y squared. And so now notice it's in that format where the a value is the 10x, the b value is the 3y. So we'd end up with, when we take these, plug it into this side, 10x minus 3y, 10x plus 3y. By the way, you might not be using your formula or using this formula. Your teacher may not be using it. Like, you may just be going from this straight to that. You might just be square rooting this to get that, square rooting that to get this. But in case your teacher wants this extra step to be able to use that formula, that's why I'm going through this. So don't, whichever way you're doing it in your class or whichever way your teacher expects, just make sure you're getting the same answers that I am. Okay, so this bracket factored into these two, but remember we still took out that 4xy at the beginning. And then we end up with those two brackets. So just be on the lookout for things you could take out initially, because notice, like, for example, here, we can't do a difference of squares here. You can't take the square root of a 2, you can't take the square root of an 18, but once you take out the 2 initially, then you end up with 1 and 9 over here. And you could take the square root of 1, you could take the square root of 9, it'd be 1 and 3, respectively. All right, so always look for stuff you could take out initially, and then from there, lots of times you could factor that remaining bracket.